Welcome to Culture, Worldview, and Origins. We're Tim and Holly Nyquist. We're in Chapter 13, Session number 8. Chapter 8 in Kuhn's book is titled The Response to Crisis. And again, that's what we're going to keep in mind as we're going through the chapter, in that when there's an anomaly or something that the box paradigm cannot explain or does not explain, how does the scientific community respond to that novelty? He says, let us then assume that crises are a necessary precondition for the emergence of novel theories, and ask next how scientists respond to their existence. Okay, so Kuhn is saying that there is a necessary crisis of something novelty, that to motivate or to push for the emergence of a novel theory, then there must be a crisis point. It has to come to a crisis in some way. Though they may begin to lose faith. Now, that's an interesting concept because we're talking about science. And science is normally, we think of based on reason, and reason the bottom floor and faith is the top floor. But as we're seeing that paradigms are built on theories, and theories are assumed by belief, but that they believe that the world is this way. So that's why Thomas Kuhn goes to, though they may begin to lose faith, and then to consider alternatives, they do not renounce the paradigm that has led them into crisis. They do not, that is, treat anomalies as counter instances. Counter instances being something that defies or that completely negates the paradigm, something that is against it. So in other words, he's saying that they do not treat anomalies as counter instances, though in the vocabulary of philosophy of science, that is what they are. So it's kind of semantics. They're saying that, okay, it's an anomaly. It's not a counter instance, but it's anomalies that then are finally become counter instances, then that paradigm cannot or does not respond to. These hint what our later examination of paradigm rejection will disclose more fully. Once it has achieved the status of paradigm, a scientific theory is declared invalid only if an alternate candidate is available to take its place. Okay, so it's not counter instances or it's not anomalies that bring down a paradigm. What brings down a paradigm is if only there is a paradigm that is waiting to come in, or that has been building in momentum to replace the other one. And so it's not just counter instances, or it's not just anomalies, even though those can maybe be the impetus for the other counter paradigm or the counter instances. So these hint at what later examination of paradigm rejection will disclose more fully. Once it has achieved the status of paradigm, a scientific theory is declared invalid only if an alternate candidate is available to take its place. So we can't declare something invalid, or we can't just say this paradigm doesn't work, this paradigm is out, this paradigm, because science has to have a paradigm to function. And so if there's no paradigm, there's no science. And that's what was Kuhn called prehistory, is that there was not a consensus of paradigm. And so there was a lot of different schools that were addressing the issues of light and how it travels and how do you define light, and then the gases and oxygen. There was not a fixed paradigm. And so there was not a fixed way of doing science, and when there's not a fixed way of doing science, then it leads to what is called confusion more than error. Thomas Kuhn says, but it does mean what will ultimately be a central point, that the act of judgment that leads scientists to reject a previously accepted theory is always based upon more than a comparison of that theory with the world. It's by faith. Okay, so it's by faith that the scientific community is or has embraced a paradigm and a specific theory. So if it is by faith, then, and since it is the paradigm that interprets the data, then it's not going to be the facts that bring down a paradigm, because the facts are interpreted data. What's going to bring down a paradigm, he says, is something else, is always based upon more than a comparison of that theory or paradigm with the world, because that paradigm is using its matrix to interpret the world. And so what is making a change of paradigm has to be more than just facts or data from the world. The decision to reject one paradigm is always simultaneously the decision to accept another. And the judgment leading to that decision involves the comparison now of both paradigms with nature and with each other. So it's not just nature interpreting the anomalies, but it's also how the two paradigms compare to each other and what each paradigm offers the scientific community. So different rules and different theories offer different benefits. So this community then, looking at these two paradigms, are going to compare not only the paradigms and how they interpret the world, but they're going to look at the paradigms and how they affect the scientist himself. It has often been observed, for example, that Newton's second law of motion, though it took centuries of difficult factual and theoretical research to achieve, behaves for those committed to Newton's theory very much like a purely logical statement that no amount of observation could refute. So once a theory is accepted as scientific and it's within the paradigm, then there's no amount of observation that can refute it alone, because observation is influenced by theory, habit, prejudice, and culture. So no amount of observation is going to bring that theory down, because that theory is the one doing the observing. So what then brings down a theory? Something much like that will also happen to the generalization that scientists fail to reject paradigms when faced with anomalies or counter instances. Why? They could not do so and still remain scientists. If science can't function without a paradigm, then you can't be a scientist without a paradigm. So you're not going to discard a paradigm, because then that would make no sense for you. That would mean that you are no longer a scientist, because a scientist is one that faithfully follows the paradigm. Once a first paradigm through which to view nature has been found, There is no such thing as research in the absence of any paradigm. To reject one paradigm without simultaneously substituting another is to reject science itself. This is kind of a reformulation of the previous quote, is that science, to be a science, requires definition, requires rules, requires boundaries, requires a paradigm, requires a theory to make it go by. And to be a scientist, they have to follow the paradigm rules. And so if you say that paradigm is in crisis, or that paradigm is no longer functioning, then you can't discard it until you have another paradigm to compete with it or to replace it. And that's what the bottom line is. To reject one paradigm without simultaneously substituting another is to reject science itself. So that is why that one paradigm can survive for a long length of time, even if it's producing a lot of anomalies or counter instances, if there is not another paradigm coming up to be able to replace it. For what is it that differentiates normal science from science in a crisis state? Not surely that the former confronts no counter instances. Okay, so we have normal science, and normal science is functioning according to the paradigm, and everybody is in agreement and in consensus and working forward with that paradigm. But what is the difference between then normal science and a science in a crisis state? It's that even a normal science confronts counter instances, but they call them anomalies. And those are puzzles. So that is what scientists and what Thomas Kuhn calls them, puzzle solvers. That's what they work on. So what is the difference then between the normal science that has anomalies or that has puzzles to solve, and a science paradigm that is in crisis, that has many counter instances? And he's saying, so not surely that the former confronts no counter instances. They both are confronting counter instances. So then what is the difference? When does one theory or one paradigm pass from normal science to a science in crisis? He goes on the contrary, what we previously called the puzzles that constitute normal science exist only because no paradigm that provides a basis for scientific research ever completely resolves all the problems. So a normal science will always have problems, but they're called puzzles. A science in crisis has counter instances, which are anomalies, which are puzzles. So how do we then transition from normal science to a science in crisis? Accepting those that are exclusively instrumental, every problem that normal science sees as a puzzle can be seen from another viewpoint as a counter instance, and thus as a source of crisis. Okay, so that's what Thomas Kuhn is emphasizing again, just what we said earlier, is that what one paradigm calls puzzles, another group or paradigm that is coming up could call them counter instances or anomalies. So again, it doesn't seem to be a sharp line between that. When does normal science enter into the realm of instability of being called a science in crisis? Copernicus saw as counter instances what most of Ptolemy's other successors had seen as puzzles in the match between observation and theory. So Copernicus, in his time, there was a lot of other astronomers that were seeing the same things as he was seeing, but they were calling them puzzles to be solved, and Copernicus called them counter instances. They are too outside the box to be solved. They are a counter instance that is resolute and that needs some other theory or rules to explain them. Furthermore, even the existence of crises does not by itself transform a puzzle into a counter instance. There is no such sharp dividing line. So Kuhn is saying that, okay, even though there are the existence of crisis does not itself transform. The existence of a crisis does not itself transform a puzzle into a counter instance. There is no sharp dividing line. So that's what we're looking at, is that, okay, so when does a anomaly, when does a puzzle become a counter instance? Is that just a personal then decision of a few or the majority, or how do things move on? How do things, and that's what this is, the response to crisis. That's the name of the chapter. How does each scientist then respond to the crisis? Copernicus responded by looking outside the box, saying that there's got to be a change in rules. Instead, its object is to solve a puzzle for whose very existence the validity of the paradigm must be assumed. Failure to achieve a solution discredits only the scientist and not the theory. If we're looking at the categories of puzzle or counter instances, anomaly, if you call this puzzle, or you're unable to solve this puzzle, and you call it a counter instance, failure to achieve a solution discredits only the scientist and not the theory. So I'm sure that was the same with Copernicus, in that in his time he maybe was discredited because he could not make the observation fit the theory. The general thinking is that the theory is good, and therefore if the scientist cannot explain it according to the theory, then the scientist has failed, not the theory. But science students accept theories on the authority of teacher and text, not because of evidence. What alternatives have they, or what competence? Okay, so here we're getting back into where do students of science learn from? What do they learn from? And it's they learn from textbooks, lectures, and laboratory experience. Thomas Kuhn is saying the textbooks are teaching a certain view of science, image of science, that does not teach the student how to really know the rules or think about the rules. So he says, but science students accept the theories. They accept them without analysis, really, of what is the metaphysics behind them, what are the rules behind them, what are the underlying theories, and what are the implications of that implicitly, because they accept the theories on the authority of the teacher that's giving the lectures, that assigns the textbook readings. Not because of evidence. What alternatives have they and what competence? So a science student graduating and coming into the field, on what competence is he going to be judging a theory when he hasn't been equipped to really understand how a theory, what is it composed of? What are the rules? What are the explicit and implicit metaphysics of those theories? And what is Thomas Kuhn saying is that a new student coming in, they're the ones that are least grounded into how we always did things. But they are also trained in the same tradition. So they don't have the competence to question the theory or to question their superiors as to why this doesn't work. How then, to return to the initial question, do scientists respond to the awareness of anomaly in the fit between theory and nature? And that's the title of the chapter, the response to crisis. Very often, scientists are willing to wait, particularly if there are many problems available in other parts of the field. That seems kind of counterintuitive in that if you come to a big problem that defies being explained by the current theory, instead of calling it a counter instance, you go to another problem because the field is full of problems. And I guess the other ones are called puzzles. And so if you can then work on more puzzles, you stay within the paradigm and you don't make any problems. But if you call it a counter instance, then by whose authority are you calling it a counter instance and not a puzzle? So there's kind of a fine line there, and it's kind of like, well, then how does science ever change? Very often scientists are willing to wait. To continue to be a scientist, they would have to wait. They'd have to wait for better instruments, for maybe more knowledge to be able to understand how to explain it better. And so they, particularly if there are many problems available in other parts of the field, many puzzles. The problem is labeled and set aside for a future generation with more developed tools. Or finally, that the case that will most concern us here, a crisis may end with the emergence of a new candidate for paradigm, with the ensuing battle over its acceptance. If a scientist chooses not to go look and work on other puzzles, but he chooses to take on this counter instance now that he's looking at, then what he's doing is elaborating or will elaborate another paradigm, because he can't challenge the one paradigm without offering a counter paradigm. And there will be an ensuing battle. Is it worth it? Is it worth it to somebody in the science field to put their reputation on the line and possibly be ostracized and left without work by challenging the current paradigm? The transition from a paradigm in crisis to a new one from which a new tradition of science can emerge is far from a cumulative process, one achieved by an articulation or extension of the old paradigm. So Thomas Kuhn is kind of putting another nail into it, and he's saying in this scenario, it is not a linear successive building of knowledge of the science field, but it is actually a revolutionary change, revolutionary meaning that it is a sudden and complete change from one world and one way they looked at it and the tools they used to look at it with and the data or the facts that were produced by those tools to almost a new world that is seen in a different way. It's the same world, but seen in a different way with different tools that produce different interpretations of the data or facts. So he's saying it's not a cumulative process. It's a paradigm shift that then shifts the whole, as he's said before, and we'll say again, politics. It's like somebody else, one political party got voted out and a new political party voted in, and that new political party is not going to continue the same projects and in the same direction and the same philosophy as the previous party if they are competing parties. They will start over and they will institute their own paradigm. Rather, it is a reconstruction of the field from new fundamentals, a reconstruction that changes some of the field's most elementary theoretical generalizations, as well as many of its paradigm methods and applications. If we look at it as political, and as one whole party, political party, is voted out, and a new party comes in, it's similar in that it's a reconstruction of the whole field with new fundamentals, the reconstruction that changes some of the field's most elementary theoretical general, as well as many of the paradigm's methods and applications. Talk about methods and applications. And that's what we're talking, we come into this and we look at the house paradigm just for bringing it back in to say, okay, remember that we've got the Weltbild on one side, which is the world picture, and then the Weltanschauung, which is the world view, viewing through the picture of the Weltbild. And then we come to a model, how we apply it, how it works. And the viewing is associated with the term theory, because theory comes from the Greek word theorein, which is spectator, which has where we get the word spectacles, and that we look through them at something, observing, and our methods change because something has changed in the lower level. Some of our beliefs, basic beliefs and rules have been modified, which then will change our system of thought, which will then produce different methods. So when another paradigm comes in, it starts from not quite the bottom, but close to it, and inserts their own rules and inserts their own system of thought, which then produces their own methods. Instead, the new paradigm, or a sufficient hint to permit later articulation, emerges all at once, sometimes in the middle of the night, in the mind of a man deeply immersed in crisis. The new paradigm emerges all at once. It's like January 20th, where you have the inauguration or the installation of the new president. Boom. Things change right from that day forward. There's a whole change of paradigm. And that's what Thomas Kuhn is saying, is that there's a whole change of paradigm that happens. It may be a slow build up to it, but once it happens, it's a revolution that happens very quickly. And how do they get the ideas for this revolution? Where do these thoughts and theories come from? Well, sometimes in the middle of the night. I don't think he's suggesting that maybe that some of the scientists work day and night. But as we've seen in other instances where a lot of ideas in the scientific field actually came to the scientist in the form of dreams. And it was a dream that led them to this solution, to this problem, whether it be the theory of relativity. Albert Einstein, you can look up the book on his dreams and what he had. Or René Descartes, how he came up with the scientific method, the different ways. Again, it was through his dreams. And so it's kind of like, okay, so what Thomas Kuhn is acknowledging here is that it emerges all at once, sometimes in the middle of the night, in the mind of a man deeply immersed in crisis. So how do we respond to the crisis? That's the name of the chapter. Confronted with anomaly or with crises, scientists take a different attitude towards existing paradigms. Each scientist takes their own attitude. And you can feel it, you can see it within the group. Does it start to splinter the group or divide it? Is it equal? Is it just one or two rebels? How is it? And the nature of their research changes accordingly. Okay, like Copernicus, his research changed and he started looking at the stars and the heavens a little differently, looking for patterns that would support his change of theory. That wraps up session number 8, which response to crisis. How do we respond? How does the scientific world respond? And obviously when a crisis comes, to name it a crisis is to step out of the paradigm, because you're switching from crisis to puzzle, or from puzzle to crisis. And if you are a team player, you stay with the team solving puzzles. And if you come across a puzzle you can't solve, then you put it away till later for someone else to solve when there's more instruments or better instruments to be able to analyze the problem. The other way to address it is to call it a counter instance then. And if you call it a counter instance, now you're leaving the box and you're leaving the paradigm, and you're running the risk of the whole scientific world going against you and against what you might be promoting. But your investigation, the way you do science, will follow the paradigm, and the paradigm that you choose to stay with. This is session number 8. We're on chapter 13, Kuhn's critical thinking. We're Tim and Holly. If you'd like to communicate with us, you can through the addresses here on the board. Thank you very much.